All right, I appreciate you guys coming today. Today I'm going to be talking about clean code here at Code on the Beach. My name is Thomas Meadows and I currently work for Beeline. It's over off of St. Augustine Road if anyone doesn't know where it's located. Excellent company. I have been coding on and off since I was about 10 years old. So I've seen 3 decades of software development and how languages have changed, tools, frameworks, things like that. This presentation is going to be very, very biased based on that opinion. You may disagree with me on a lot of points. If you want to disagree with me during the presentation, I will strongly disagree with you, maybe in a not so nice way, but we can debate it afterwards in a nicer manner if you want. But the reason I started software development was because I was like 10 years old and I thought it would be cool to code games. So my brother gave me a book about this thick with games in it and a Commodore 64. So that's how I started learning how to code. I would write the entire program into a Commodore 64 on my CRT TV. This is long before Visual Studio ever came out or any type of IDE. So if you made a mistake, you had to go back and debug every single line that you didn't type correctly. After a while, I would finally get a game working, and it was, I would play the game for 5 seconds, and that's how I realized that that's how I learned that I love to code more than I love to actually play video games. And that's kind of a strange thing, but it's kind of like a rat and a mouse, or like a mouse in a maze type of thing. You have a problem, you get a solution, and then you get a reward, and you move on to the next problem over and over again. It's very rewarding to be a software developer, in my opinion. So, my talk primarily is based on what I've learned over the years. And I am talking on clean code, which is based primarily on what I've learned from Robert C. Martin and what he's written in his book called Clean Code. If you don't have a copy, you should get one. What I would call it is the Bible of software development. If you've never read this, then you are extremely at a disadvantage. If software development were a religion, I would call this our Bible. This presentation is going to be largely mirrored after what Michael Potts did for the keynote last year on ethical coding, as well as what Joe Short did yesterday on software economics from Feature 23. And if you look at all 3 of the presentations we've done, I would probably describe it as the trinity of software development. The most important things to know as a software developer. So, anything other than that? I think I'm good on that screen. So why do we care about clean code? Technical debt, just bottom line, technical debt. What causes technical debt in software engineering? I would start and say the number 1 reason personally is language barriers. Software is written by people from many different nations and many different tongues, but we all write it in English. So more often than not, if English is not your primary language and you're working with people who know English, there's going to be a barrier there. Other problems that may cause technical debt are things like overcoding, like coding for features you don't need, over testing. Nobody needs 100% code coverage most of the time. When you have the features that your customers use, if 90% of if 10% of your code covers the feature, 90% of the features your customers are using, you're probably writing too much test. Even the guy who created test-driven development said he regretted doing it because it was the worst decision he ever made, because it's caused people to spend so much time writing code that you don't actually get software pushed out the door. Over-architecting is another big problem with technical debt. Everyone is on the hype train to get the latest and newest technology and get on board with it. Often or not, it doesn't help the situation. It just hypes up your developers to learn something new. So there's a good article on that called Hype-Driven Development. If you want to look that up later, you can. And how it can impact your software development cycle. Database decisions is another big one. Oftentimes you see very bad database decisions like states. People don't need states generally in a database. When you start creating excess tables just to create tables, you start creating more and more technical debt. Like some things you just need a software package for, or you just need to hard code it as constants or something. Like if you have less than 50 items and it's not something that's going to change on a per client basis, maybe you're making a bad database decision. Because the longer your product stays around, the more you're going to realize, I have to go through 7,000 tables to find the one I'm looking for, and then figure out what all they're connected to. Some of those tables are completely unnecessary. Custom code is another one. People often will write things for open source tools that are already available, or they wrote it before the open source tool was available. And now you've created technical debt because you needed a solution that wasn't available at the time, now is available. Now you have to migrate to the new open source solution. Outdated technology, that can be another one, but not necessarily. Only in the event where it can create security flaws. Knowledge gaps is a big one today because your oldest senior developers tend to have knowledge of all your technical debt because they seem to be the ones who coded it. When they leave for a new company, your new coders come in, they have no idea about the technical debt your old software developers have created. So we end up creating an endless cycle of new developers coming in, creating technical debt to replace the technical debt of the old developers. So especially with rising wages in software development, it's created a huge problem. What does not fix technical debt? Rewriting the code base. Netflix went bankrupt. I mean, not Netflix, Netscape. Sorry, Freudian slip. Netscape Navigator, if you've ever used it, is the basis for all modern web browsers. There is still code today in Chrome, Firefox, Brave, whatever browser you're using, that is from Netscape Navigator. All of us still use Netscape Navigator to get today, whether we realize it or not, to some extent. A lot of it's been modified, but there is some original code from Netscape still in modern browsers. They went bankrupt trying to rewrite everything because of technical debt. Changing the coding language. If you think changing the coding language in this day and age is going to make your code better, you're sorely mistaken. It's just going to create even more technical debt. Company I worked for, they decided they were going to switch everything to Haskell. The only problem they had was that no one knew how to write Haskell. They thought it was the coolest coding language ever. They ended up needing a Haskell expert. Guess how much that Haskell expert cost? Does anyone know? $200,000 a year. You could have just stayed in JavaScript and got a $60,000 intern or $70,000 intern. What problem are you trying to solve by switching to another language? Writing more tests. It's not going to fix bad code. You can write more and more tests, but if you didn't write the code right the first time, every time you go to read it, you're not going to understand it. Moving the code somewhere else. Moving it from on-prem to the cloud. You're still going to have the technical debt when you go back and read the code. It's not going to fix anything. You're just going to have the code in a different place. Having a more stringent hiring process. Do you really need more people that know how to do algorithms? Has anyone in here written an algorithm in the past 10 years, or has it been copy and pasted? One. Got the math guy over there. So, design patterns. Design patterns are great, but it's more like introduction to clean code is what design patterns are. Like the very, very basics of how to write good code. Switching coding I have that up there twice, I apologize. Introducing a new technology to the technology stack. That's more hype-driven development. We had a guy that wanted to put all of our metrics into Redis at a company I worked for all the viewing time for all the TV show, and make it the permanent data, make it the permanent data store. So Redis is a permanent data store. I chuckled at the idea, but the CEO approved it. So it became 3 years worth of technical debt to get rid of it. Redis should never be used as a permanent data store. It's a temporary caching solution. But over time it became a huge problem. Now we're on to what does fix technical debt. Refactoring the code base and not rewriting the code base. Rewriting the code base is years and years and years of process. You follow by example. You don't want to be the next Netscape navigator to go under by rewriting your code base. A company I know in Gainesville was on their third rewrite of a new software, and the company was only like 6 years old. They completely rewrote their entire code base 3 times, and they're probably headed for a 4th if they're not worried about clean code. Develop new projects to release in tandem with old technology. As opposed to rewriting your code base, there is a strategy you can use, like a sidecar pattern. You set up new sections of your site, kind of like what we're doing at Beeline. We're creating a new section and developing the same product with upgraded technology so that we can phase out the old feature eventually. Track and phase out features that use legacy technology, that should say that are no longer used, sorry. Oftentimes product managers will try things out and no one will end up using the feature. Feature gets left in the code base, no one ever uses it, it just sits and sits and sits and sits, and it's just code that if someone came across, they wouldn't know what it was because it's an unused feature, and every time someone has to read over it, it's technical debt just to figure out what it is and what it does. Getting rid of technology no longer used by the industry, sometimes. This applies in cases of like if you're using Fortran or COBOL. Because your development costs will get so high that it will be impossible to maintain. Like if you want to write code in Fortran or COBOL these days, you're talking $200,000 plus salaries. No one usually wants to write it though, so those jobs go largely unfilled. It's really hard to write in those languages. And I'll go over more of that on another slide. So, teach your staff to discuss and write clean code more often. That's how you really fix technical debt. So, let's see how much time I have here. Making pretty good time. What is good code and what is bad code? Largely subjective questions. And if I asked anyone here in this room, we would get a lot of different answers. If I asked someone who just came out of school, just got their computer science degree, this is the answer you would get. Good code is code you write. Bad code is code you read. Has anyone ever been able to not read their own code that they wrote last year? The year before? 2 years before? 3 years before? Hopefully everyone's getting better, as you go. But, it's almost sad that they invented get blame, because you go and look at get blame, you're like, who wrote this code? And you're like, oh, it was me. Shh, don't tell anyone. So, how can we all get better? And that's mainly the point of this talk. So that's me listening when someone says that on the previous screen, is that code you read is the bad code. So the reason we all have problems with that is what I believe is largely we've gone into too far into a computer science focused area for software development. When you write code, it is written in something called a programming language. It's not written in math. It's written in a language, and when you speak a language, people should be able to understand you, depending on the dialect of where you're from. And when you think about coding, as you write it, you have to realize you're saying, if something happened, then I want to do this. It sounds just like a sentence. And when you write code, it should sound like sentences as you flow down the path to reach your destination. If it's not flowing like a sentence and no one can read it, then it's not really a language anymore. You're trying to, it's like trying to decrypt hieroglyphs or something. The better we write the code, the less technical debt we're going to end up having, is the point of that. So if it read like perfectly written prose like Shakespeare, anyone could open up the code and understand what was happening, regardless of if they work in your company or not. So if when we write code, we should typically look at it from the perspective of, if someone didn't work in my company and they came and looked at this code right now, would they understand how it worked? And would they be able to troubleshoot it if there was a bug in it? And it's kind of hard to get that mental state, because oftentimes we're just trying to get it working. And once it gets it working, we want to be done with it and move on to the next thing. Because it's like, yay, it's working, we can go on to the next thing. And that's not the thought pattern we should have. It's like, yay, it's working, now how can I get this written clean enough and in a way to where the next person that comes behind me can understand this code and continue writing from what I've already done. So from that, in this book, I have come up with what I would call 10 clean code principles, rules, or commandments, depending on how you want to look at it. Number one, I don't believe in abbreviations. You should not abbreviate. I remember back in the day when I learned how to use Express, if anyone's ever used that library before. First time I ever touched JavaScript in Node. And when I saw REQ and RES, I'm like, what's REQ and RES? But when I made my first route, I'm like, oh, that's request response. And that's often what happens with every abbreviation you come across. Else statement line count should not be greater than the if statement line count. I'm actually going to go ahead and touch on these more on next slides, so I'm just going to go over them kind of quick. You should not write else statements. Be consistent. Use linters, static analysis tools, and package managers. Keep a constants file. Declare functions before calling them. Outside classes for functional programming. Declare functions in order of their use inside classes if you're using class-based programming. Don't write files over 1,000 lines of code. Don't write functions over 100 lines of code. And functions should only have 1 to 3 parameters. I think this is very doable for everybody. Some of this stuff can be argued against or for at times, but for most part, you should be able to stay within this, rarely going outside of these patterns, and end up with code that anyone can read. So you should not abbreviate. Why do we abbreviate? Back in the early days of coding, there used to be a max number of characters when you declared variables. In Fortran, you could only have a 6-character variable. Imagine trying to describe what your function does with only 6 characters. In BASIC, it was 2 characters. You know, your biggest word you could use is 2. In COBOL, you had 30 characters. In OS 360, it was 8 characters. 8 characters, you know, it's not terrible, but you know, any English word longer than 8 characters and you're gonna have trouble describing what your variable is. Hungarian notation came about as a result of all of these character limits, which Microsoft has largely done away with and hated the fact that they did it to begin with, because now it's stuck in all their code. If you ever need to mess with Windows, you still have to mess with something called an HWND. Like, no one knows what the heck that acronym means until someone tells you what it means. And the variable limits is largely the reason that happened. And that is basically why abbreviating is a bad idea, because typically, no one's going to know what your abbreviation means until you tell them. And if it's something like internal, like it gets even worse, because we had something called CDFs, and I don't think anyone here would know what that is unless you worked at our company. And what that is, and we had it all over the code for a feature I was working on. And what it is it's a client-defined field. So clients could define their own fields like text boxes and things. And so you wouldn't know what that was unless someone told you. But really, there's another acronym that's really common in the industry called UDF, which are user-defined fields, which is really what it is, but clients have access to define them rather than just a user. And if we would have just, you know, wrote out the whole thing, you know, every single developer ever since that piece of code was written would not have that same question. If it actually read client-defined field, no one would question what it was. So that's the primary reason for not abbreviating. You know, obviously there's always exceptions because you want to be consistent. And if other people are abbreviating something, you probably should continue to abbreviate it for the most part. You should not write else statements. The reason for that is because of else hell, right here that we see. This code, if you're not senior, is going to take you quite a bit of time to dissect. Based on the vehicle's class, a math operation is multiplied based on distance travel. This could have been easily avoided by taking all of this, putting it into a class, and rather than using these else statements, just use if statements only, and then return the amount as the result of your function. And it would be much more clear what's happening in your function as opposed to this. This is what we call if else hell. And if you get into it, you know, it becomes a really big problem. And I know a lot of people have heard about callback hell in JavaScript, but if else hell can be just as bad, and that can happen outside of JavaScript. It can happen in C#, Python, it doesn't matter. And if you're going to write an else statement and break the rule, just make sure that it's not bigger than the if statement. Plain and simple, because You could use an anti-pattern and make the else statement your if statement and the if statement your else statement, if that makes sense. If not, I'll talk about it a little bit more later. Be consistent. Linters, static analysis tools, editor RC files, anything that can force everyone on your team using the same code practices is awesome. Style guides. There's a class in here after this called for static analysis tools that I'll probably attend because I don't always use them myself. Hard to set up and hard to enforce. Keep a single source of truth for static constants. This is a very rare one. Not a lot of people do that, but if you need to change a URL and you have a constants file, you're going to have a lot easier time than trying to write a regex to change the URL over 37 files of copying the API. That's just an example. People who follow the pattern tend to have cleaner, easier to read code. Functions should be declared before calling them. This is more of an old school thing than anything because newer functional programming, it doesn't matter. JavaScript, it doesn't really matter because the whole file is loaded before anything's processed. I think Python, it may still matter. If you try to use a function before it's declared, at least on version 2 it was, the compiler will throw an error. So you should always declare a function and then call it in the function beneath it. Just for consistency throughout all coding languages that you're using. Don't try to alphabetize your functions, just put them in the order that opposite of what they're called. So this is actually the exact opposite if you're using classes. Because ever since classes have came out and people have started using them in things like C#, the exact opposite is expected generally. I don't know why they started doing it the other way for classes, but typically the top function in your class is the main function, and then all of your sub-functions are below that class. So functional and non-functional coding is somewhat at war with each other when it comes to function declaration. But as long as you're following the pattern and everybody else is following the pattern, then we're being consistent. Obviously, there are times when you can break any of these rules, but you should generally try to follow them. Don't write files over 1,000 lines. Don't write functions over 100 lines. See how much time I have here. 31 minutes, okay. Files over 1,000 lines are obviously bad because they're going to take more and more time to read. A developer I work with thought it was a good idea to place every single validator for every single route in our application into one file. The file became over 10,000 lines long, impossible to read, impossible to work in, impossible to tell which function belonged to which route. There could have been hundreds of other ways to write it, but he chose to do it that way mostly because he was a new coder and couldn't think of another way to do it and didn't ask for help. Wasn't a good code review process. You know, there's 1,000 things that went wrong with that. Don't write functions over 100 lines of code. Typically, no one should ever exceed 100 lines, but if you are, you probably need a lot of sub-functions, and your function is doing too much. Typically, functions should not do that many things. They should read like actions, like getting user from database or get user from database, and then allow parameters. Like that's a function. Like if it's get user from database, adding 7,000 collections and calculating the mass of the sun, it's not a function anymore. And it probably should be broken out significantly. Functions should only have 1 to 3 parameters in a single responsibility principle. The single responsibility principle is what I just discussed. Functions should only have a single responsibility. They shouldn't do 300 things. And if you're using the single responsibility principle, you should only end up with 1 to 3 parameters in your function. Otherwise, you're probably making a mistake somewhere. Or you can, there are ways to kind of get around that. You can pass in a config object and things like that, or make a class. Sometimes it makes more sense to make a class with functions in it than it does to make a super big function. And it's a little subjective, but you know, keep the number of parameters down if you can when you're coding. So, very quick before I go into my example, does anyone have any questions, or is that not clear enough about anything in particular? Okay, so on to the example. Geometry Wars, the new project. Clean Code Part 2, this is interactive sample. Our project, or the biggest lie you can tell yourself as a developer, the code is working and no one is ever going to read it when I'm done with it. Because if your code's working and no one's ever going to read it, your project's dead. It's not making any money, and you may as well delete it when you're done. So we have a new project ready to go. Our interns are ready to go to start coding it quickly. They know agile development after all. Super fast coders ready to go. Stage 1, the project manager's request. I need you guys to make a button that makes a circle. The requirements must be able to make more than one circle. Circle must appear in a horizontal wraparound. Circles must have 100 pixels between them. Let's see if my Alt-Tab works okay. I can bring up the project. There we go. Here's the project. I'm going to create a circle. Great, our button works. Okay. I'll tell our project manager we got our circle working. Let's go to stage 2. The project manager needs an upgrade. Looks great, guys. But now we need squares. I want a toggle that makes squares or circles. All right, so go back to the drawing board here. We're gonna, hopefully if my live reload works. Might have to restart the server here. Refresh is F11, right? F5. F5. Okay, there we go. We got our circle, and we got our square. I hope you guys like View and Viewtify because that's what I wrote this in. So it shouldn't matter though, because we're talking about clean code, not the software architect decision. Let's see, next step. We need more features to try to sell this. Let's do rectangles and hexagons. All right, the guys are like, yeah, we got this. We'll go rectangles, hexagons. This is actually much harder than intended. What did I do? Did I accidentally hit back? All right, there it is. So circles, rectangles, hexagons. I keep hitting my side mouse buttons, I think is what it is. All right. Okay. Let's see if this works. Sometimes I do need to restart the server. This does work though. All right, I might just skip ahead to the next step. Let's see. Step 4. Okay, step 4 was to create colors. So we can now pick a color, and we have to restart the server. Live reload doesn't always play nice, unfortunately. And doing it really see if it works anyways. Okay, well, at least it's working. There we go. Now our icons are back up. Okay. Back to the presentation. So, got our rectangles and hexagons. Black is so plain. Can we get some colors, change the colors? Stage 5, we need borders. So, it's only 6 stages, so hopefully, maybe this will work okay for us now, as intended. All right, we got our borders now down here. Select borders. Do a random border here and color. And we got our borders and our colors. Okay, so that's what the project manager wants. That's what they got. Now they demo to the clients for the final stage, and they decide they want to show the clients the cool product we've been working on for a really long time. It turns out our clients like the project so far, but they have some concerns and they want some customizations. Like, that's never happened before to anyone. Our requirement this time is to introduce custom code for each of the companies. VaxCo doesn't want hexes because they can't have borders. NerfCo only wants black borders. AnimalCo only wants green circles, but the other shapes don't matter. SimCo doesn't want borders at all. So now what do you do? So what does the code look like, guys? Here's the working one, but I added you're a startup. You're gonna tell them no? They're your only 4 customers. You don't have any more. There's no income stream other than, you know, what these guys give you, or you're gonna have to, you know, sell some more stock. So, I think the code's up here still. Oh, this is kind of the part where we analyze what we wrote. Now this also, it was like my 5th or 6th iteration to get it into a somewhat decent state just to start. But I went through, oops, I did not mean to go to the last one. That's the last slide. So, to talk about this, this is what our devs have written us and given us to work with. And you're the lead developer and you have to analyze it. We have two methods. It doesn't seem so bad, does it? Just for all that just happened, we have create geometry and we have what happens when a geometry changed. So, so far, it looks okay, but you know, if this continues to be worked on, this is going to create a lots of problems down the road. This may be normal code most of you work with, but I would find this completely unacceptable. Maybe if you were just trying to get it done fast and cheap and test the product, see if it worked, maybe it'd be okay, but at some point down the line, this technical debt has to be paid, because me coming in here and looking at this, if I didn't know what the project was at all, I wouldn't know what was happening. I see there's a current client in here and it's doing things based on the client. There's some kind of created geometry thing that something's being pushed into. Some kind of HTML template. Like, is someone who's never seen this code before, that's what I see. Like, and you kind of have to look at code from the perspective of someone outside of the company peering into this. So there's a lot of different ways that we could fix it, but this is how I would start to fix it. I have a 5-step thing here. So you got 15 minutes still, so we're making good time. The first thing I would do is I would break some of this out into with some extra functions, just to clean it up a bit. So I'm going to check out my. We're not actually going to do the changes. We're just going to pull the branches that I've already made the changes on, so I can tell you what I'm talking about. Let's see, did it update? Okay, so yes, here we go. We've gone ahead and changed it to where we are. Now we have more than 2 functions. We have our geometry change still, but now we have a function for creating a circle. We have a function for creating a square, one for a rectangle and one for a hexagon. Makes sense, right? We have 4 geometry, so we should have 4 functions. And our create geometry still exists. It just now nicely calls the geometry that's there. Now this still can get better. This code can still get much better. The next thing we're going to do is we're going to fix some if-else hell that's in here. All of these if statements are making things really hard to read. So we're going to fix some if-else hell. Down in our create geometry, we're now using returns instead of else statements. Cleans it up just a little bit. Under each of our geometries as well, we are also now returning for each event. For each client, we are returning the geometry that client requested. So if I came in from outside the company, I'm starting to understand a little bit more about what's happening, but I still don't completely understand what would be happening if I was someone from outside the company. So stage 3, of cleaning this up, we're going to add a base geometry create function. And what that's going to do is that's going to take that crazy div thing that was happening under each of these geometries, and we're going to make a create base geometry function that's going to automatically create the div that gets injected into the web page. And all we have to do is pass in circle and some parameters. So we pass in the geometry type, the color, and the border color, and it automatically spits out the correct geometry. So again, now this is starting to get much easier to read. So all of our functions are now calling this create base geometry. So we can tell that this is probably where our geometry is actually getting created. Not in the logic of creating the square. Again, this can be cleaned up even more. How we clean it up more? I often don't use switch statements, but this is one of those rare events where I think rather than using returns, we could probably switch to a switch statement, because logically, in English, it tells the reader that we're doing things based on each client. So if I were to read this in English, we're now saying, create a square. We're basing how we create the square based on the current client. And for each client, we're going to create a geometry this way for the client. So we're now in a more presentable code area, because it starts to read more like a language and not like someone who's just getting the project done. The last thing that I wanted to do, I thought some things could be renamed and cleaned up a bit more. There's actually quite a lot of cleanup I ended up doing in stage 5. So this is what I ultimately decided on would be the cleanest way to write all of this. Did it check out? Yeah. We're on stage 5. So this did not change much. Create base geometry. I have, okay. Yeah, this is the other thing that I want to say is the geometry changed, has now actually grown. Like we don't have less code here. This is a case where it's actually gotten more code, but in writing more code, we've actually made what's happening clearer. I don't know how many people are aware, but you can actually, assign the result of a Boolean test to a variable. So in this case, we're going to assign it to something called circle button selected, square button selected, rectangle button selected, and hexagon button selected. This tells us which button is selected that the user is clicking on. So we're saying, like logically in English, if the circle button is selected, then select geometry. If the rectangle button is selected, then select the rectangle. Like this reads hugely different than just checking to see if the select button group is 0. This reads like perfect English to me. And when I was to come in from outside the company, I would say, oh, that makes perfect sense. If the circle button's selected, set the selected geometry to circle. Only a fool wouldn't understand that. I don't think I changed create base geometry at all in this one. And these are still switches. Nothing changed here. And then I did the same thing down here. And I renamed this function create geometry clicked. Why did I rename it create geometry clicked? Because that's what the user's doing. They're clicking create geometry. So it's an action describing what's happening on the screen. Create geometry was clicked. And what happens is based on what's selected. If the circle button's selected, we create a circle. If the square button's selected, we create a square. Perfectly logical English. So it really didn't take much more time to think about this. I mean, and it depends on what you're doing. Maybe you don't have enough time to go through it and do all this, but the base of your project, you know, at the heart of your project, if you love your project, you know, take the time to do this. You know, sometimes project managers understand and they don't need to get a project right out the door. If they know you're going to clean something up to where you're not going to get technical debt 10 years down the road, just say, we need a little bit more time to clean. Look, it's working. We could throw it out the door right now, but we need some time to clean this up and make it look a little bit better, more presentable, so that when we come back to it, if we need to add more features, we're going to be able to easier to tell what's happening and do it better. And if we, as software developers, were able to write all of our code like this, we had no deadlines, we wouldn't have to rewrite anything. We wouldn't have to, I mean, this is refactoring. This is what needs to be done in 90% of the software on the planet. You know, unfortunately, we have deadlines, new products that need to be rolled out. We aren't always in maintenance mode, but the more this is done, the less technical debt you're going to have. And if you ever have a problem with this code, you're going to come back and you're going to easily be able to solve it. It's not going to, you know, if it was written the way it was before, you would spend a lot more time trying to troubleshoot it than troubleshooting this code right here. I guarantee it. And this is basically using all of the points I made in the 10 commandments that I created. Not a single else statement is here. And it's perfectly legible. To be honest, I haven't written an else statement in about 5 years. And if I have, it's only for like a line or two. I hate writing else statements because of this reason. It makes your code illegible. Also, the further to the left you push your code, the more legible it's going to be. Once you start going out with your indents, you probably need to look into creating some subfunctions. The further to the left it is, the easier it's to read. It's a really simple thing to know. And with that, we got about 5 minutes left. I don't really think I have anything else to say. Think about things before you approve if you're doing a code review. A couple minutes of fix errors can save thousands of hours to future coders. And keep a thesaurus handy, or merriam-webster.com, or whatever dictionary you use. That's pretty much it. Any questions? You can debate me now if you want.